Hey, folks. I've got a quick couple examples for you about determining equivalent resistance of a circuit or a circuit branch. So I've got the first diagram up there for you. So if you want to pause the video for a second and copy that down, that'd be great. All right. So what is the equivalent resistance of this branch of a circuit between X and Y? Okay. So there's point X and there's point Y. So usually, and most of the time, we can use our rules that we developed for series and parallel resistors. So if there's series resistors, remember series means and. If you're Joe Electron, and you, like in this example, if you're Joe Electron and you go through R3, you have to go through R2. It's an and. You don't have a choice, right? So R3 and R2 are in series. Parallel is an or. If you're Joe Electron and you're trying to get from the top of the battery to the bottom, you can go through R1 or R2 or R3 and end up back in the same spot or in the same spot. That's parallel. So again, series is and. If you go through one, you have to go through the other, no choice. Parallel is or. If you go through one or the other, you end up in the same spot. Okay, that's important to remember. All right, so in this case here, if this were the example, it'd be really easy, right? R1 and R2 are in series. If you go through R1, you have to go through R2, so you would add those up. So for instance, let's say all of these are 20 ohms. So you would do R1 plus R2 is 20 plus 20 is 40. You would do the same thing down here. You would do R3 plus R4, that'd be 40. And then this top branch would be in parallel with this bottom branch. If you're Joe Electron, you can go through the top branch or the bottom branch and get the Y. So you would do the 40 and 40 in parallel, and you would end up with 20 actually for your answer. Now, by the way, why would you put 420 ohm resistors in this orientation? Well, it turns out if you do this, your resistance is still 20 ohms, but now you can run more current through here before you fry the resistors. So that's why you would do it. So that's all well and good, right? However, what if we add a resistor in here? I'm going to add a resistor right there. We'll call that R5. Well, now you got a problem. Now you can't use those rules at all, the series or parallel. Nothing in this circuit is series or parallel to each other. For instance, R1 and R2 are no longer in series because if you're Joe Electron and you go through R1, do you have to go through R2? No, you can go down through R5, right? And then, for instance, R1 and R3 are not parallel either. If you go through R1, you end up there. If you go through R3, you end up down there. Since you're not ending up in the exact same place, they're not parallel. So in this case, nothing in this circuit now is series or parallel. So I guess we're stuck and we can't find REQ. Well, that's a lie. You can find REQ. Here's the secret. What you do is you take this whole thing and hook up a battery to it. Okay. And you make up a voltage for the battery. You decide, make it 100 volts, make it something easy, right? And then you're going to do the circuit analysis that you've been doing on all the other problems. So like, maybe you call this current here, I1, and then maybe this current here is I2, and then this current would be I1 minus I2. You guess on that current, maybe I'll guess I3. This current there would be I2 minus I3. And this current here would be I1 minus I2 plus I3. So I1 minus I2 plus I3. Sorry for the sloppy writing there, but you don't even have to write this down. So here's the idea. You would solve and get I1. Okay, so that's your goal, is to figure out I1. And then we know that the total voltage of the battery is equal to that current, the total current coming through the battery. So that would be I1 times REQ, and you'd solve for REQ, and that would be your equivalent resistance of that circuit. So you would use the stuff we've been doing, all the circuit analysis, to solve for I1, and then that would give you REQ. Okay. Another example. Okay. Then you're going to draw this out with me. So let's say here's point X. All right. And let's say you've got a resistor there, and a resistor there, and a resistor there, and then here's point Y. Okay, we'll call these, R1 and R2 and R3. And I asked you to find the equivalent resistance between X and Y. Well, that's easy enough. It'd just be, they're all in series. It'd be R1 plus R2 plus R3. All right, then let's say I added a resistor like so. We'll call that R4. Okay, so at this point, you could still do all your equivalent resistance stuff. So for instance, R1 and R2 are in series. You'd add them up. And then that branch would be in parallel with R4. So then you could do the 1 over stuff to get that total resistance. And then that entire branch is in series with R3. So you would add whatever this total resistance is plus R3, and that would be REQ. So that's all well and good, right? But then what if I did this to you? What if I put a 5th resistor right there? We'll call it R5. Now you're in trouble. Okay. No resistor, no pair of resistors in this whole thing is series, nor are any of them parallel. So for instance, if you look at R1, R2, they're no longer in series because if you go through R1, do you have to go through R2? No, you could choose to go through R5. So they're not in series. Parallel, like R5 is not parallel to R2. If you go through R5, you end up over there. If you go through R2, you end up over here. You don't end up in the same exact spot. So they're not parallel. So nothing here is series or parallel. So how would you figure out the overall equivalent resistance of the circuit? Well, again, you would pretend you hook up a battery, give it a value, find this current, okay, and then you would do V equals IR, and that R would be the equivalent resistance of the entire circuit, okay. So you generally can find equivalent resistance of any circuit as long as you can hook it up to a battery and calculate what the current should be and eventually find the current through the battery. When you can, obviously, use these rules. When you use these rules, you want to do 1 or 2 or 3 resistors at a time, find parallel ones. So if I give you, like for instance, when I gave you this branch without R5 in there, so the blue guy isn't there, well then you can do like R1, R2 series, R3, R4 series, and then this top branch is in parallel with the bottom branch. So you knock out a couple resistors at a time. Same thing here. Until I added R5, you could just do your rules. R1, R2 were in series. That was in parallel with R4, so you would combine all that. And then that whole thing was in series with R3, so you just add them up. However, there are some situations like these two I've drawn with the R5s in there where now you can't do all that, so you got to hook up a circuit. All right, so I hope that example is helpful, and thank you very much.